So we can give students an example like this, x squared plus 7x plus 10. And we're just going to give them the pieces and ask them to make an area out of these. Now, if students have done the distributive property before, they might kind of know how the pieces fit together well. But if they haven't done the distributive property with binomials, then this can be really a challenge because they haven't seen this pattern before. What students will do is they're going to have to split up the way that they arrange the x pieces. So they might arrange it this way, for example. And it's fun to watch the students work and to kind of struggle with it. They also really want to, for this, to put the pieces in the wrong orientation. So they'll want to take these x pieces and put them like this next to the x squareds. And you really start seeing these, the rule breaking for the first time. So we definitely want to be aware of that. So once students have this made, they can read off the length and the width as x plus 2 and x plus 5. And it doesn't matter if they put the plus 5 down here and the 2 across. Because of the commutative property of multiplication, it doesn't matter which order we put those two factors in. And so we can give students a couple of examples, just all with positives like this, just so that they get used to making the pattern. And what's going to be really important is how they go about this work more quickly and that they see what the key is to doing this work. The key is these units, because every time they arrange these units always have to make a rectangle. And so if you look at this number 10, there's only 2 ways to make a rectangle out of these 10 green units. One way would be to do a 10 by 1. And if they did a 10 by 1, then you would need 11 x's to fill in. But they only have 7 x's to use, so that's not going to work. The other choice is to make a 5 by 2 rectangle, and they can see that they're going to have 5 x's and 2 x's for the 7 x's that are going to work there. And there's often a lot less combinations for the units to make rectangles than it is different ways to add up to 7x. And we can do other examples with them where maybe this is a prime number where there's only one way to arrange these, or there's maybe 2 ways like this 10 to arrange a 5 and a 2 or a 10 and a 1, but a lot of ways to arrange that middle term. And that leads students then to looking towards this number here, thinking of how do I factor this, and then how does that relate to the x's. For these examples that we're doing, they will probably discover that they're looking for what multiplies to 10 that adds to 7. Or in other words, what multiplies to give us our units that adds to our x terms. However, that won't always be the case as we go up in variations, but the idea of what we're working with and the patterns will still hold. So we want students to be able to articulate that and see the reasons why this works, and then they can go ahead and factor with this variation. Do follow-up activities like the matching cards. They can do this in drawing, and I think that's also really important that, yes, they're using the materials, but then they can go faster and do more work when they're doing the drawings, and that's how they can do their explanations. So we can ask them questions not just to factor this, but draw a picture and explain what the different combinations are. And there's lots of other different follow-up activities we can do to get students thinking about the work, as well as simply just practicing. The last note that I do want to say is that when students write these, we do want to have these put in parentheses. So we would write this as being equal to x plus 2 times x plus 5. And if students just write it like this, then it looks like it says x plus 2x plus 5. So we might want to emphasize at some point that students should be putting these in parentheses when they write these as products. And that's really about it. So students can explore. We want to give them lots of times with the material so they can come to the discovery of the rule themselves. And then we can help them articulate that rule and then apply it in different variations.